Hello students, welcome back to the class, and a small recap of what all we studied in the previous lecture was we deduced an expression for the time period of oscillation of a simple pendulum, and also we studied about damped oscillation. And in our today's class, we will be studying about what is forced oscillation, resonance, and we shall solve few problems on the particular chapter which we are dealing with. Now, if I consider forced oscillation, you can see the definition here. If an external periodic force applied on a body will not oscillate with its natural frequency but oscillates with the frequency of external force. So, what is that? It is very simple. If you understand the exact meaning of the definition. So, anything which oscillates, or if I consider a forced oscillation, it is something that it oscillates not by its own but only when there is a external force given to it. A body will not oscillate with its natural frequency but oscillates with the frequency of external forces. So a oscillation or external force which I give, so depending upon that there is a oscillation that happens to a body. This is called as forced oscillation. And if I consider the resonance, you can see here I have given you two statements here. So whichever is comfortable for you, you can take it. So it is called as a frequency matching condition. So what kind of frequency matching condition? See now, coming to the second definition, which is very easy and simple to understand when I give you an example for it. So first let me read it. A phenomenon in which an external force or any or a vibrating system forces another system around it to vibrate with greater amplitude at a specific frequency of operation. See children, so I consider myself sitting on a swing, and my father, yeah, is back of me. He starts pushing me where me I'm on a swing, and he tries to push to make me oscillate greater and greater so that I can enjoy my play. And now if I consider myself who is sitting on the swing, I experience greater force. How would I experience a greater force? Because of my dad who is pushing it, and I would consider my dad to be as external force. So it says that a phenomenon in which an external force, that is my dad, okay, external force or vibrating system forces another system around it. Another system is myself, who where I am sitting on a swing, okay, another system around it to vibrate. I'm doing a to and fro motion in a swing, right? So vibrate with greater amplitude. So what is my dad doing? He is trying to achieve a greater swing, greater amplitude, greater push. So with greater amplitude at a specified frequency of operation. So what is the aim of the external force? To create a greater amplitude and to achieve, or to achieve the matching condition. So that what would I consider it to be as frequency matching condition. So they are matching each other. So what is the aim of the external force? Is to produce a greater amplitude of a system around it. So that is called as resonance. So hope you understood. For at this point, the whole syllabus is completed, and we shall go start solving the problems. Now, the first problem here, you can see that the body executes simple harmonic motion along the x-axis. So what is happening? There is a simple harmonic motion a body is executing along the y-axis. Now its displacement varies with time according to the equation. So you have got a equation for the displacement. Y is equals to 0.5 sine into 100 pi t, where y is in meters and t is in seconds. So just they have given you one expression and they are telling you to calculate the amplitude, period and time, period and frequency of motion of the particle. So how would you calculate using just using this expression? That is the thing what you're going to do now. Now if I consider, I put this solution, you have to write solution here and then start to write the expression given. Y is equals to 0.5 sine into 100 pi t. Got it? Now what is the value or the expression given for the displacement along the y-axis? See children, if it is y-axis, you're going to write as sine omega t in your equation. In case if they tell you x-axis ಅಂತ ಕೊಡ್ತಾರೆ, so what would you write in your equation? You would write cos omega t. So this is one of the point you have to remember here. Now if I consider y is equals to a sine omega t here, so you have got the displacement formula, this one, as we derived in our previous lecture. Now what am I going to do? I don't have any other choice. I have to compare the exact formula of the displacement and the displacement expression given in your question. So obviously if I compare, yes, it is the same, both are same, but the values are changed, and on comparison you can see that a is equals to 0.5. What is it? It is your amplitude. What is your amplitude? It is 0.5. So then what would be your omega here? So t you can see it is common, and what is the value of omega where you can replace in this equation? It is omega is equals to 100 pi. So this is your value of omega. Now they have asked you to find out what all amplitude. You got to know what is your amplitude. You have to find out what is your period time t, and what is your frequency f. You have to find out. So what is the value of omega? You have got a formula, that is omega is equals to 2 pi f. You have got a value. So what you're going to do, in the place of omega you're substituting whatever the value you have got here. Omega is equals to 100 pi. You substitute here, what would you get? 100 pi is equals to 2 pi f. Now what can I cancel here? I can cancel pi, and it is, after you calculate 100 by 2, which is equal to 50, then rearranging your equation, you would get f is equals to 50 hertz. As you have got frequency, as I had given you the expression or relationship between frequency and time, your time would be equal to 1 by f. Then what is your value here? Your time, it would be, your time period would be 1 by 50 seconds. So this is how you calculate only when they give in a question. So if they give you the displacement alone, what you're going to do, one thing you have to remember is your formula. Through your formula you can just go on deriving. Now going to your second question, what is it? So here also they have given you what? Only your value of displacement, the displacement of a particle executing simple harmonic motion is given by y is equals to 0.3 sine into 300 t, that is your theta, plus what is that, the extra thing they have given you? It is your phase. It is called as initial phase. What is the initial phase? In the sense, I will tell you about it. First, let me read the question. Okay, and they have given you one extra value, that is your initial phase, where y is in millimeters. Understand, your displacement is happening in millimeters. And calculate the amplitude, frequency, angular frequency, that is your omega, initial phase. So I have told you initial phase is your phi. Now, what is that initial phase? Always remember, it is the value which tells you the value of sine function. So, at what point it is? That's it. So, when it tells you the value of a sine function, when your time is 0 and your x will be equal to 0. So, that is what you call it as initial phase. Now, let us go on solving. I would write solution here, you have to write it. And now if I consider the equation given here, y is equals to 0.3 sine into 300t plus 0.25. Now what is the value of displacement of the formula given you? It is y is equals to a sine into omega t plus, what is it, plus phi. You have to include this initial phase whenever you see this kind of equation. So it is, you are seeing an extra thing here, then you have to remember it is your initial phase, that is your phi. So when you're writing your formula, you have to include your phi too. And now if I can start comparing, a is equals to 0.3. What it is in millimeter, it is not in meters nor in anything, it is in millimeters. Only in a small displacement there is a amplitude you can see. And if I consider your omega, there is no substitution, no pi, nothing as in your previous problem. It is given directly, it is omega is equals to 300 radians per second. Okay children, now the third one is, what are the things you have to find here is frequency, right? So we understood how to or how we got amplitude, omega is angular frequency, and you have to calculate your frequency. Now what is the formula? What is your omega? It is 2 pi f. So 2 pi f is equals to, it is not 150 children, it is 300, because 2 pi f is equals to omega, right? So 2 pi f is equals to omega, and your omega value would be equal to what? 300. So 150 should be replaced by 300. Please make a note of this. Your 150 should be replaced by 300. Now f is equals to 300. Okay, you're rearranging it. What is 2 pi here? It is almost equal to 6. Why is it? It is 3.14. What is the value of pi here? 3.14. 3.14 into 2, you are multiplying 3 2s are 6, and it is almost near to 6, right? So what would you write? 300 divided by 6 you would write here. And what is f after dividing? It is f is equals to 48 hertz. Now the fourth one is phi. You can write it directly. So this is how you calculate your values of amplitude, frequency, angular frequency, initial phase. Hope you understood. Next, going to the third problem here, it says that now speaking about the third question, it says the maximum velocity of particle executing simple harmonic motion is 15.7 meter per second, and the maximum acceleration of a simple harmonic motion is 2465 meter per second square. So they have asked you to find out the frequency and amplitude of simple harmonic motion. So solving, we are continuing with our problem. The solution for this is
First, we can write the expression for the maximum velocity. So always remember the expression for the maximum velocity is V maximum is equals to A omega is equals to 15.7 meter per second. So here the value and the formula should be written together so that we can further calculate the value of frequency and amplitude. So next expression for maximum acceleration. For acceleration, what is the formula? It is A is equals to A omega square, which is equal to 2465 for meter per second square. So what is the technique we have to find out or use here is to take the ratio between velocity and acceleration, so that acceleration divided by velocity, substituting here you would get A omega square divided by A omega. So after cancelling, what are the things would remain in this part would be omega, which will be equal to, after calculating omega is equals to, you have got the value that is 157 radian per second. So already you have got the value of omega, and it is very simple for you to calculate the value of frequency now. So what is the value of omega? I had told you in the previous lecture, it is 2 pi f, right? So if I consider 2 pi f is equals to 157, so introducing the value of omega here, so what would I get? F is equals to, so rearranging this, I would get to find the value of f, I would keep f as it is, which is equal to 157 divided by 2 pi. So later on, for the calculations for f would be equal to 25 hertz. So this is the value of your frequency, and the remaining thing, what is it? We have to calculate it as the amplitude of simple harmonic motion, right? So now for amplitude, V is always maximum. So if I consider the value of a velocity here, so what am I doing? I'm squaring on both the sides of the value of whatever I have taken V to be. V is equals to A omega. So I have squared it on both hand sides. So now as I squared it, what would I do? I would keep A as common, and have put A omega square in a bracket for my convenience. And now what would I do? A is equals to, have you seen this thing anywhere? Yes, it is the formula of your acceleration. Here you can see, yes, this is the formula of your acceleration. So I would write A maximum. Yes, I can write that. So now what would I get? I am substituting this amplitude value A as it is, rearranging V square maximum divided by A maximum. So what is this V square? We have got the value of V already, right? Just squaring it. When you square, substitute, divided by A maximum, a value of acceleration. If you put, you where at finally you would get the value of amplitude. You are calculating the amplitude, so it is equal to 0.1 meters. This has the end of the chapter, children. Hope I have made all the concepts very clear to you. And if there is any of the doubts regarding this chapter and also the previous chapter which I've done, please come back to me, clear your doubts, where the concepts are very important for you, not for the sake of your marks. It is the sake of your future, to learn the concept, to learn physics well. So I would say best of luck to you. Thank you, children.